Hello everyone, this is Hatem Elshazly and I'm a PhD student in the Barcelona Supercomputing Center. In this video I will be giving a brief overview about my research activities within the Expertise project. So the Expertise project is a multidisciplinary project that aims at studying and addressing the challenges that prevent the full simulation of turbomachinery components, for example, engines of aeroplanes. In order to carry out these activities, the Expertise project is decomposed into multiple work packages. So we are concerned in this video with work package 4, which is a work package that I work in, which is high performance computing. To give an overview of what's happening is we have a mathematical and analytical model that we want to convert to a computational model. And because this kind of simulations usually exhibit sophisticated and complicated calculations, they have to be executed on supercomputers. However, even with executing them on supercomputers, they take a lot of time, so their application in real life scenarios is almost impractical. So within my research, we address this performance bottleneck and we try to achieve better performance using this kind of supercomputers to make their application real life scenarios more practical. My first activities is using hybrid programming models. Hybrid programming models means that we use two kinds of programming models to achieve the best of both kinds. So we use tasks, which are a representation of your application that can be scheduled to special hardware devices, and we use multiprocessors inside these tasks to execute I/O in parallel. And of course, this has a potential to achieve a lot of performance improvement. Our next contribution is introducing I/O awareness, which is avoiding I/O congestion. Just like when a lot of cars in the highway can create a jam, the same thing can happen with I/O requests and storage devices. We solve this problem by constraining the execution. This way, less I/O requests can use the resource at the same time, which leads to better performance. We applied these techniques to a domain decomposition application, in which the application is decomposed into multiple the application decomposes the problem into multiple parts. And as you can see, this can achieve a huge performance improvement that can reach up to 40% of the total execution. And by this we reach the end of the presentation. Thank you very much for listening, and goodbye.